NASA spacecraft will pass closer to the center of our solar system than any human-made object ever. It will surpass the closest a human-made object has ever come to the Sun, moving at a mind-bending speed. A NASA probe is about to make history by flying closer to the Sun than any spacecraft before. On Christmas Eve, December 24, 2024, NASA's Parker Solar Probe made history once again by venturing closer to the Sun than any spacecraft has ever dared before. This remarkable achievement, which marks humanity's relentless pursuit of understanding our nearest star, brought the probe within just 3.8 million miles, 6.1 million kilometers, of the Sun's surface. To put this in perspective, that's about 1/10 the distance between Mercury and the Sun, a realm where temperatures soar and the challenges to both technology and human ingenuity are immense. This flyby, the 22nd of Parker's daring close encounters with the Sun, wasn't just a routine part of its mission. It was historic in that it brought the probe closer to the Sun than it ever has been or ever will be. NASA scientists had meticulously planned for this milestone, which they anticipated to occur at exactly 6:53 a.m. Eastern Standard Time, 11:53 Greenwich Mean Time. However, during such perilous close approaches, communication with the spacecraft is temporarily lost. The Sun's intense radiation and magnetic interference create a sort of radio silence, making it impossible to maintain contact. As a result, NASA won't know for sure whether the spacecraft survived its fiery encounter until December 27, when it is expected to re-establish communication with Mission Control. The Parker Solar Probe is no stranger to setting records. Since its launch on August 12, 2018, the spacecraft has continuously redefined the boundaries of human exploration and engineering. For instance, on September 21, 2023, Parker became the fastest object ever created by humans, reaching an astounding speed of 394,161 miles per hour, 635,000 kilometers per hour, 635 times faster than the speed of a Lockheed Martin F-35 fighter jet, which tops out at about 1,200 miles per hour, 1,930 kilometers per hour. But even that incredible feat was outdone during this latest flyby. On Christmas Eve, Parker shattered its own speed record, traveling at a mind-blowing velocity of 430,000 miles per hour, 692,000 kilometers per hour. At such a pace, Parker could travel from New York City to Los Angeles in just 20 seconds. These extraordinary speeds are not achieved solely through the probe's propulsion system. Instead, they are the result of careful gravitational assists, also known as gravity boosts, provided by 7 strategic flybys of Venus. These planetary assists have allowed the spacecraft to accelerate and adjust its trajectory toward the Sun, each time bringing it closer to our star's infernal atmosphere. The most recent of these Venus flybys occurred in November 2024, just weeks before the record-breaking Christmas Eve approach. While breaking records is impressive, it is not the primary objective of the Parker Solar Probe. The spacecraft's true mission is to unravel the mysteries of the Sun, particularly those surrounding its outer atmosphere, the corona. The corona is a region of intense scientific interest because it defies our current understanding of stellar physics. Under normal circumstances, you would expect temperatures to decrease as you move farther away from a heat source. This principle holds true within the Sun itself. The core, where nuclear fusion occurs, is the hottest region, reaching temperatures of around 27 million degrees Fahrenheit, 15 million degrees Celsius. The layers surrounding the core, the radiative zone and the convection zone, are progressively cooler. However, this trend mysteriously reverses in the Sun's outer layers. The photosphere, the visible surface of the Sun, has a temperature of about 7,400 degrees Fahrenheit, 4,100 degrees Celsius. Yet the corona, which lies thousands of miles farther from the core, is inexplicably much hotter, with temperatures exceeding 2 million degrees Fahrenheit, 1.1 million degrees Celsius. This puzzling phenomenon, known as the coronal heating problem, has baffled scientists for decades. It's akin to discovering that your kitchen gets hotter the farther you move away from the oven, a counterintuitive observation that demands an explanation. The key question driving much of the Parker Solar Probe's mission is this: what mechanism is responsible for heating the corona to such extreme temperatures? Several hypotheses have been proposed over the years, but none have been definitively proven. One leading theory involves magnetic reconnection, a process in which the Sun's magnetic field lines break and reconnect, releasing massive amounts of energy in the form of heat. Another hypothesis suggests that Alfvén waves, magnetized plasma waves that propagate from the Sun's surface, could be transferring energy into the corona. Both of these phenomena are tied to the Sun's dynamic magnetic field, which is constantly shifting and interacting with charged particles in its atmosphere. By venturing closer to the Sun than ever before, Parker is uniquely positioned to gather data that could shed light on these mechanisms. Equipped with a suite of advanced instruments, the spacecraft is capable of measuring the Sun's magnetic fields, solar winds, and energetic particles at unprecedented levels of detail. The Parker Solar Probe's mission would not be possible without its groundbreaking thermal protection systems. The spacecraft is designed to endure temperatures as high as 1,300 degrees Fahrenheit, 700 degrees Celsius, during its closest approaches to the Sun. This is achieved through a revolutionary heat shield made of carbon composite materials, which keeps the probe's instruments at a relatively cool 85 degrees Fahrenheit, 30 degrees Celsius. The heat shield is complemented by an autonomous cooling system that pumps water through radiators to dissipate heat. Additionally, Parker is equipped with a sun-facing sensor that ensures the heat shield is always correctly aligned to protect the spacecraft. If the probe were to veer off course, the sensor would trigger an automatic correction to reorient the spacecraft. Although Parker's Christmas Eve flyby represents the closest it will ever come to the Sun, the spacecraft's mission is far from over. 2 more close approaches are scheduled in the coming months, each designed to collect additional data about the corona and solar wind. The next flyby is planned for March 22, 2025, followed by the final scheduled encounter on June 19, 2025. During these passages, Parker will come almost as close to the Sun as it did on Christmas Eve, traveling at similarly record-breaking speeds. These final flybys will allow scientists to refine their understanding of the solar corona and test their hypotheses about its heating mechanisms. The insights gained from the Parker Solar Probe's mission have far-reaching implications, not just for solar physics, but also for our understanding of other stars and the broader universe. By studying the Sun up close, scientists can develop models that apply to stars of different sizes, ages, and compositions. Closer to home, Parker's findings could also improve our ability to predict and mitigate the effects of space weather. Solar storms, which originate from the Sun's corona, can disrupt satellite communications and power grids and even pose risks to astronauts. A better understanding of the corona could lead to more accurate forecasts of these events, helping to protect critical infrastructure on Earth. The Parker Solar Probe's journey is a testament to human ingenuity and our unyielding desire to explore the unknown. From its record-breaking speeds to its ability to withstand the Sun's intense heat, the spacecraft embodies the spirit of innovation that has defined space exploration for decades. As Parker continues its mission, it brings us closer to solving some of the most enduring mysteries of the cosmos. Its journey reminds us that even in the face of seemingly insurmountable challenges, the pursuit of knowledge knows no bounds. This Christmas Eve, as Parker raced through the Sun's corona at nearly 700,000 kilometers per hour, it carried with it the hopes and dreams of scientists, engineers, and dreamers around the world. And while the spacecraft itself may never return to Earth, the discoveries it makes will illuminate our understanding of the universe for generations to come.